All right, today we are going to apply systems of equations. We're on pages 15 and 16. Okay, so with several ways to solve a system, we can often choose a method that is most practical based on the system. So we're going to read the description for the method and that each student chose and draw a line that connects the description of each student. Okay, so we have the graphing method, we have the substitution method, and we most recently learned about the elimination method. So Sam wants to solve the system using substitution because one of the equations is already solved for a variable. So if I look here, nothing is really solved for, okay? This one, we have both of them are solved for. And for this one, we have one of them that is solved for. So when that is the case, that is usually meaning that substitution is the best method, okay? Tess wants to solve her system using elimination because one of the variables has opposite coefficients. So if I look here, a 3 and a -3, those are opposites. I also notice that they're also in standard form, which tells me that elimination is probably the best way. Okay, and then Bo wants to use graphing because both equations are written in slope-intercept form. And if you look right here, both of these are solved for, or both of them are in slope-intercept form, which makes me think that graphing is the best method, Okay, now what we're going to do is we're going to solve Sam's method, Tessa's method, and Bo's method using the method that they chose. Okay, so for Sam, we are going to use substitution. So I am going to substitute in this equation into every y I see in the top, so right here. So I'm going to have 3x's plus 2y's. Instead of y, I'm going to write -x plus 10, and that equals 23. Okay, 3x's minus 2x's plus 20 equals 23. That would be 1x plus 20 equals 23. That makes 1x equaling 3, so x equals 3. Now to figure out what y is equal to, I'm just going to use the one that's already solved for. Y equals -x, so -3 plus 10. -3 plus 10 is 7. So my solution would be 3, 7. Okay. For Tess wanted to use elimination because they were already in standard form and they already had opposite coefficients with the y values. So I'm going to add them together. X plus 5x is 6x. -3y plus 3y eliminates to no y's. And 9 plus 27 is 36. So then x would have to equal 6. Then to figure out what the other variable is, the y variable, you can pick either one. So we'll do the top one, x minus 3y equaling 9. So x is 6 minus 3y equaling 9. I would subtract the 6 and get 3, divide by -3, and I would get -1. So when x is 6, y would equal -1. All right, then the last one says to do it by graphing. And so we could graph these. I have no doubt that you guys could graph those. I'm actually going to use the substitution method because I love the substitution method, especially instead of graphing. So I'm going to put this equation over here with the y. So I'm going to have 1/2 of an x minus 14. That's the first equation. And that's going to equal the second equation because they both equal y. So if they both equal y, I can set them both equal to each other. So then I'm going to add 2 x's and get 2.5 x's minus 14 equaling 6. Then I'm going to add 14 and I get 20. And 20 divided by 2.5 would be 8. Okay, then to figure out the other coordinate, we could use either one. 1/2 of the x minus 14, 1/2 of 8 is 4. 4 minus 14 is -10. So when x is 8, y equals -10. Again, obviously you could graph those. That is the method that we said would probably be the most efficient, but I do like substitution. You could just set them equal to each other. Okay, so for these problems, guys, you just have to pick which method that you prefer for each of them. Okay, so when I look at this one, I really like elimination. So if they are basically both in standard form, I'm always going to use elimination. Whoopsie. Now, if you looked at that and you were like, man, that top problem is basically almost y equals, you could obviously use substitution. So I'm going to use elimination just because that's what I see first. This one is solved for and one is not solved for, so I am going to use substitution. Okay, and then this final one, neither of them are really easy to solve for, so I'm definitely going to use elimination for this one. Okay, so for elimination, I have, these are different numbers. This is no number, so if this was a 2, a positive 2, it would make life really easy. So I'm going to multiply everything by 2. I would get 4x plus 2y equaling 16. Then I can add them together and get 1x equaling negative 1. So that means that x equals negative 1. Oopsie. Then I could plug in either one. I'm going to do the top one. 2 negative 1s plus y equaling 8. Negative 2 plus y equaling 8, which would mean y would equal 10. So this solution is negative 1, 10. Okay, substitution for the second one, I am going to substitute in this value in for every y that I see in the top. So 3x plus 2y's equaling negative 5. Then I'm going to solve it. 3x minus 4x minus 10. Negative 1x minus 10 equaling negative 5. Then I would move and I would add 10, and that would be positive 5, which means that x equals negative 5. Okay. Then to figure out the other one, y equals negative 2x minus 5. We just figured out that x is negative 5. Negative 2, negative 5 is 10. 10 minus 5 is 5. So the solution would be negative 5, positive 5. Okay, for the final one, again, you could do it a couple different ways. It's kind of up to you. I see 5 and a negative. So if this was a negative 5, I'd be a happy camper. So I'm going to multiply by 5. I'm going to get negative 5x plus 30y equaling 110. Okay, I'm going to put the top one below it just so I can see. Okay, these would eliminate. This would make 28y's equaling 112. And then 112 divided by 28 is 4. Okay, then we would have to figure out what the x is equal to. So I'm going to do 5x's minus 2y, so 2 4's equaling 2. Which would be 8. Then I would add the 8 and get 10. And then I would get x equals 2. So my solution would be 2, 4. Okay. And then on the back page, we just have word problems, just kind of, again, putting all of this together. So angle R and angle S are complementary angles. That means it has a sum of 90 degrees. If the measure of angle R is 3 more than 2 times the measure of angle S, write and solve a system of equations to find the number of degrees of each angle. Okay, so I'm just going to say that angle R, we're going to use R, and angle S, we'll use S. So the first condition, it says it's complementary angles, which means they have a sum of 90 degrees. So that means that R plus S has to equal 90 degrees. The second condition says if the measure of angle R is 3 more than 2 times the measure of angle S. Okay, so there is my system. Okay, when I think about what is the best method, I'm going to think that substitution is the best method because R is equal to this amount. And then I could just substitute this into every time I see an R value. So that would be pretty easy to solve for. So instead of R, I'm going to write 3 plus 2s. Okay, then I'm going to write the rest of the equation, plus s equals 90, which means we have 3 plus 3s equaling 90. Then I would take away the 3 and get 87. And 87 divided by 3 is 29. Okay, that means the measure of angle S is 29 degrees. Okay, then for to find the measure of angle R, we would do angle R equals 3 plus 2 S's, so 3 plus 2 29s. 2 29s would be 58, and 58 plus 3 is 61. Okay. I also know we're right because if we add them together, it creates a 90-degree angle. It's crazy. Okay. A professor gave an exam of 31 total questions. Multiple choice questions were worth 2.5 points and open-ended questions were worth 5 points. If the total possible points earned was 100, write and solve a system to find the number of multiple choice and the number of open-ended questions, or just the number of multiple choice. Okay. So I'm going to use M for multiple choice, and I'm going to use open-ended, I'll use P, or I'll use E for open-ended. Okay, so the first constraint is that it has 31 total questions, which means the number of multiple choice plus the number of open-ended has to be 31 problems. Okay. The second constraint is the point value of them. Okay, multiple choice questions are 2.5 points each. Okay, where open-ended questions are 5 points each. And of those 31 questions, that's a total of 100 points. So that's why we have our second equation, 2.5m plus 5e equaling 100. Okay, now because we want to solve this, both of them are in standard form, so I'm going to use elimination. Our goal is to figure out multiple choice, so I'm going to be smarter and eliminate the e's, okay? So this is a 5e, so I need to make this a negative 5e. And 31 times negative 5 is negative 155. Okay. Then these would eliminate, and this would become negative 2.5 multiple choice. It would equal negative 55. And then we would divide by negative 2.5, and we would get m equals 22. So there are 22 multiple choice. If we want to figure out the number of open-ended questions, there's 31 total questions, 22 of them are multiple choice. So that would be 9 open-ended. But it did just ask what the multiple choice was. Okay. Mike and Maria both work in sales. So far, Mike has made 12 sale calls and plans to make 2 calls every hour over the next several hours. Maria just began work and plans to make 5 sale calls per hour over the next several hours. So with this, guys, we don't really know how many total calls they're going to make. It's dependent on how many hours that they work. So that means I need to write in slope-intercept form. Okay, so for Mike's situation, okay, the number of calls that he makes total changes. So he starts with 12, and he plans to make 2 every hour. Okay, so we're going to graph him by starting at 12 and going up 2 calls, so up to 14 every hour. And so then we'd be at 16, and then we'd be at 18, and then we'd be at 20, and 22, and 24, and 26, and 28, and 30. So after 9 hours, he would get through 30 phone calls. Okay. Then we have Maria. Maria just began working, but she plans to make 5 every hour. Okay, so she just began working. She's going to make 5 an hour. So she would make 5, and then she would make 10, and then she would make 15, and then she would make 20, and then she would make 25, and then she would make 30. Okay. So it looks like they cross right about here, and that solution would be 420. And in the context of this situation, after 4 hours, they both would have made 20 calls. Okay, number 10, the graph line represents the first equation in a system of equations. Use the graph to answer part A and B. Okay, so here's the first one. If the second line passes through 0, 2, and 12, 6, so 12, 6, find the solution of the system. Okay, so I'm going to find the slope of this. So it looks like it goes up 4 over 12. 4/12 is the slope. Okay, and that would be equivalent to 1/3. So it looks like the equation's y equals 1/3 x plus 2, because that's where it starts on the y-axis. Okay, I'm gonna go back to 2, and I'm gonna go up 1. So I'm up at 3, and I'm gonna go over 3. I'm gonna go up 1 more, and I'm gonna go over 3 again. So it looks like graphically it crosses at 6, 4. Okay. Okay. Now for this next one, I'm gonna use a different color. Okay. If the second line passes through 2, 6, and -8, 6. Okay. Well, that's easy. It looks like it just crosses through -4, 6. Perfect. Okay. So for today, there will just be some practice, and I will see you guys later.